In a nutshell, Ethernet IP's implicit or I/O messaging transfers one block of data from the PLC to the drive's Ethernet IP module, which is then forwarded to the drive, and it transfers a different block of data from the drive's Ethernet IP module to the PLC. This is all done transparently in the background, so all you have to do is mess with these guys. If you change one of these, then Ethernet IP automatically changes the drive to match it. If the drive changes one of these, then Ethernet IP automatically updates that over here in the PLC. Once it's set up, you don't have to do anything. It just works. Ethernet IP's implicit messaging is great for those times when you want your controller to monitor or update some drive parameters periodically with minimal hassle and effort on your part. All we have to do is create an electronic data sheet that lists the parameters that are in these blocks and also contains the relevant Ethernet IP stuff that describes the drive. Then we import that electronic data sheet into the PLC so it knows what to expect. That's literally all we have to do. The good news is the SureServo2 Pro software automatically generates a custom electronic data sheet for you. Let's do an example. For this demo, we'll set up this Automation Direct Productivity 1000 PLC to communicate with this SureServo2 drive via Ethernet IP implicit messaging. We'll be using this Ethernet addressing for this demo because these are the SureServo2 drive's default numbers. You'll need to use the numbers that are compatible with your network. I'm assuming you have the Ethernet IP module connected to the SureServo2 drive, that it has the most recent firmware, and you know how to configure it. Check out these videos if you need help with any of that. For this demo, I just factory reset the Ethernet IP module. No other configurations needed. I have this drive set up to run a position register mode path that simply rotates this disk back and forth. Check out this video to learn how to do that. To set up the Productivity PLC to control the SureServo2 drive using Ethernet IP's implicit messaging, we'll need the PLC to enable the servo, specify the path that we want to trigger the path, and disable the servo. And just for fun, let's also control what shows on the drive's LED display. That's the data going from the PLC, the originator in Ethernet IP lingo, to the SureServo drive, or the target in Ethernet IP lingo. The drive can support up to 16 of these parameters. Let's also have some data go from the drive into the PLC. Let's monitor the status of the currently running path, the firmware version, the current drive alarm code, and the keypad button status. And we can have up to 16 of these. So we just need to do two things. Generate the electronic data sheet for the SureServo2 drive in the SureServo2 Pro software, and then import that data sheet into the Productivity PLC. In the SureServo2 Pro software, which you can download for free at AutomationDirect.com, with the drive connected, double-click on the Ethernet IP electronic datasheet generator. This list is the target to the originator list, the drive to the PLC. We want to monitor the status of the currently running path in parameter 5.123. We want to monitor the firmware version in parameter 0.0, the current drive alarm code in parameter 0.1, and the status of the drive's keypad keys in parameter 4.08. Again, we can send up to 16 of these to the originator, or the PLC. Over here, we have the parameters that go from the PLC originator to the drive target. We want to send stuff to parameter 2.030 to enable and disable the servo, and we want to trigger our path, which we'll put in parameter 5.112. We'll then trigger those paths by writing to parameter 5.122. And we want to control the drive's display via parameter 0.02. Again, you can control up to 16 parameters. Click this guy to create the electronic data sheet and save it to disk. Now we go to the Productivity PLC software, which is also a free download from the Automation Direct website. I've already started a new project and connected to the PLC. We need to get this PLC on the same network as the drive, so I'll go to Hardware Configuration, double-click on the CPU, go to the Ethernet ports tab, and enter an IP address that'll work with the drive. Now we go to the Ethernet IP tab and import that EDS file we created. Give it a name and drag that over here. Give the new device a name. We're using the Ethernet port, and the drive is located at its default IP address of 192.168.1.10. And I like to put all the status in a structure. Okay, that was all the generic stuff. Click here to add the type of Ethernet IP messaging you want. We can add a generic I/O or implicit Ethernet IP messaging, explicit messaging, or custom messaging, which will come from this electronic datasheet file we created. For the inputs to the PLC, we'll do unicast. That is, the message is sent directly to us, not multicast to everyone. And we'll have the messaging update every 250 milliseconds, or 4 times a second. The datasheet filled in the correct instance for us, and we can see that it's sending us 16 32-bit words from these parameters. So we need to put those in a data array that's 32-bit integers with 16 elements. The data output to the drive is the same thing, 16 32-bit integers being sent to these parameters. So we create an output array that's 32-bit integers with 16 elements. Now I forgot to change the poll rate when I recorded this, that's 50 times per second, but it does point out that outputs can have a different poll rate from the inputs. The configuration stuff is all grayed out because the electronic datasheet filled it in for us. This 192 bytes of configuration data contains the addresses of the parameters that will be transferred back and forth between the drive and the PLC, and some other odds and ends that the PLC needs to know. These guys contain the values at those addresses. So all we did here was assign the CPU and IP address, imported the EDS file, and created the input and the output arrays. When I hit OK, the software asks me if I want to create all these new tags. I do, but I like to increase the size of the status strings just to be sure they can handle anything that comes their way. Great! This is the drive that the PLC will be talking to in the background via Ethernet IP's implicit messaging. Let's do one more thing. I'll double-click to go back into that device and click on this monitor button to automatically create a data view with all of this stuff in it. And I'll close out of all these dialogues. I'll transfer this configuration to the PLC and flip its switch over to run mode. Let's bring up that data view where we see all the status tags in the input and output arrays. You can add some comments in the tag database to remind you what each of these is, but we're going to cover these up, so I'm not going to take the time to add tag comments. If I click this enable bit and write that to the PLC, then we see the drive's vendor ID, its formal name, there's no error, so this is blank, we're connected to the drive, there's no error flag here, and the message we got back is that we have a successful connection. Perfect. And look, we can already see the firmware version here and all the other parameters input to the PLC from the drive via Ethernet IP. I'm going to add some notes over here to remind us what each parameter is. This guy shows us the status of the drive's keypad keys. And sure enough, if I press different keys, we see the results here in real time. Cool. Let's control the servo from the PLC. Now before we do any writes using Ethernet IP's implicit mode, let's go to parameter 2.030 and enter a 5. That tells the drive not to store any writes to non-volatile memory that come in over comms. That way, if comm sends a lot of writes, you don't have to worry about using up the non-volatile memory's limited number of writes. The non-volatile memory can take millions of writes, but comms can eat that up pretty quickly if you aren't careful, so this is always a good precaution. The Ethernet IP module buffers incoming writes, and it only forwards changes to the drive. So it's not the number of writes, it's the number of writes that change a value that counts. Now I did this via the drive's keypad for our quick demo. You would normally put this in the PLC's startup code because this non-volatile memory protection doesn't survive a power cycle of the drive. Okay, let's enable the servo. I'll check to make sure it's not currently enabled. Yep. And I'll enter a 1 here and write it out. And sure enough, now it is enabled. Now we put the path we want to trigger here and we write that out. Then the drive needs to see a 0 to a 1 transition here to trigger the path. And there it is. Now if I had more paths to execute, well, I would just enter those numbers here and issue a 0 to 1 transition here to trigger each of those. We just enter a -1 back up here and write that out to disable the servo. And just for fun, let's change the LED display to show the speed and RPM. And how about the current bus voltage? There are tons of things you can show on the LED display. The codes for those are in a table in section 8.4.11 of the user manual. Of course, you would normally do all of this in ladder code, but the point here is, look, we haven't written any ladder code at all, yet we have full control over the drive simply because Ethernet IP is auto-magically transferring all these parameters down to the drive and bringing these parameters back up from the drive for us implicitly in the background with no effort on our part at all. Very cool. And again, all we really did was create an electronic datasheet in the SureServo2 Pro software that listed all the parameters we wanted Ethernet IP to transfer for us, and then imported that into the PLC. Not bad at all. Some loose ends. There are a couple parameters that Ethernet IP's implicit messaging can't control. For example, you can't trigger a path using parameter 5.007 like we did in the other videos. As we just saw, implicit messaging uses parameter 112 and 122 for that. And you can't change the digital input and output assignments via implicit messaging. You need to use Ethernet IP's explicit messaging for that. Finally, don't forget to keep an eye on the Ethernet IP module status LEDs. There's an awesome chart in the user manual that tells you what all the various blink rates and colors mean. Now keep in mind, this was all the implicit or I/O messaging Ethernet IP mode, where it automatically transfers the parameters back and forth for us. That's really appropriate for monitoring things in real time or things that'll change often. If you just need to write something once, like writing a 5 to parameter 2.030 to disable the non-volatile memory writes, then you probably want the Ethernet IP's explicit mode, where you use ladder instructions to explicitly send parameter changes to the drive. We cover explicit Ethernet IP messaging in this video. Well, that should be good enough to get you started with Ethernet IP's implicit or I/O messaging. Click here to learn more about SureServo2 and to find more videos like this one. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos like this, and click here to learn about Automation Direct's free award-winning support options.